Today I am discuss about on the topic of green chemistry. At first we talk about what is green chemistry. Green chemistry, also called sustainable chemistry, is an area of chemistry and chemical engineering focused on the designing of products and processes that minimize or eliminate the use and generation of hazardous substances, while environmental chemistry focuses on the effects of polluting chemicals on nature. Green chemistry focuses on the environmental impact of chemistry, including reducing consumption of non-renewable resources and technological approaches for preventing pollution. Now we discuss about the need of green chemistry. It has already been stated that various scientific developments in the 20th century brought about various benefits to the mankind. But all this was responsible for a number of environmental problems at the local and global levels. It is of course important to formulate guidelines and pass strict rules for the practice in chemistry, but most important is to bring about changes at the grassroots level, which can achieve by bringing about necessary changes in the chemistry curriculum in the colleges and the universities, as well as also in the secondary school. A concerted and purposive effort is needed to widest audience, bringing green chemistry to the classroom and the laboratory will have the desired effect, educating the students at various levels about green chemistry. Now we discuss about biofuels. Biofuel is a fuel derived from biomass. Biomass means the biological material derived from living organisms. So any fuel that is derived from biomass, plant or algal material or animal waste is biofuel. As these feedstock materials can be replenished easily, biofuel is considered to be a renewable source of energy, unlike fossil fuels such as petroleum, coal and natural gas, etc. Bioethanol and biodiesel are two alternative fuels developed for automobiles. Both of them can be produced from renewable resources. Catalytic hydrolysis and depolymerization of lignocelluloses produces a mixture of lignin, cellulose and hemicellulose. Selective catalyst hydrodeoxygenation transforms part of small oligomers into biofuels. Dehydration of sugar gives furfural, which is also source of valuable chemicals and biofuels. Fermentation of the oligomers gives bioethanol. Bioethanol is a liquid fuel produced from plant materials like wheat, maize, sugar beet, soybeans and sugarcane that contains starch or sugar. Biodiesel is produced of triglycerides with methanol in the presence of catalytic amount of NAD. The methyl ester of long chain fatty acids are used as biodiesel. The interesting feature is that production of glycerol by this process has a little market demand, but glycerin has been converted into propylene glycol and hydroxyacetone, also called acetone, by heating with copper fluid in presence of hydrogen at high temperature and pressure. Propylene glycol has market value and hence the overall production cost of biodiesel is reduced. Now we discuss about the formation of biodiesel. A flowchart for formation of biodiesel. R1 single bond C double bond O, single bond O, single bond CH2, single bond CH, single bond O, single bond C double bond O, single bond R1, single bond CH2, single bond O, single bond C double bond O, single bond R1. This compound is triglyceride, and this triglyceride is treated with NaOMe as a catalyst. In presence of methanol, this compound produces the mixture of glycerol and CH2OH, CH2OH and methyl ester. R1 single bond C double bond O, single bond OMe, methyl ester. And this methyl ester, the methyl ester of long chain fatty acids used as biodiesel. And this glycerol is treated with copper chromate, CH2OH, single bond CHOH, CH2OH. This glycerol treated with copper chromate, CuCrO4, in presence of hydrogen at 200 degrees centigrade, 200 psi. This compound produces acetol, CH3CO CH2OH, acetol, and this acetol is converted to propylene glycol, CH3 CHOH CH2OH. Thank you so much, sir, for watching my video.